This tutorial will illustrate how to use the Set Lateral Displacement Targets command to control building displacements by optimizing the steel frame member design based on energy principles. We will use a previously developed building model consisting of a 4-story building with steel moment frames, a first story height of 15 feet, typical floor heights of 12 feet, and the requirement that no beam depth can exceed a W18. This model has already been analyzed and the steel frame members have been selected based on strength criteria. A number of static loads have previously been applied to this model, but because we are concerned with optimizing our members based on lateral displacements, we will focus on the earthquake load case in the Y direction. To view the displacements calculated from the initial analysis prior to displacement optimization, click on the Display, Set Output Table Mode command and select only displacements. For the load case, scroll down and select EQY, our earthquake in the Y direction. On the next form, select Point Displacements, and note that the maximum lateral displacement is typically 2.19 inches. We will assume that we have a target displacement of 1.5 inches for this building, so we will need to perform a redesign and resize the members to reduce the deflections. To view the initial member sizes based on strength design only, activate the Plan view, click on the Design, Steel Frame Design, Display Design Info command, and make sure that Design Sections is selected. Note the W16 by 36 on the plan. This element will serve as the comparison element after the redesign for displacement. Next, set our target displacement for member optimization by clicking on Steel Frame Design, Set Lateral Displacement Targets command. This is the key command for displacement control. As previously stated, we would like to target the maximum displacement at 1.5 inches for the top floor. Make sure to click Add and then OK. Now start the redesign of the model, which will optimize the members for our new displacement criteria. The design is complete, and note that the previously highlighted member has now increased in size to a W16 by 40 to control displacements. Next, rerun the analysis so that the displacements will be recalculated based on the members just chosen in the redesign. Once the analysis is complete, check to make sure that the 3D view is active, and click on the Display Show Deformed Shape command and select EQY from the load box. On the 3D view, right-click on a top floor column, and note that the displacement is now 1.37 inches, below our target of 1.5 inches, so this design is acceptable. This concludes this tutorial.